Gulati, Associate Professor, CIMR Gwalior, welcomes you all in 1 week online international workshop on empirical methods in social sciences, an introduction to statistics, econometrics, and big data. Before moving further to the session on machine learning with Python, let me introduce the resource person of today's session, Mr. Dwarkesh Panchal. Sir is a data science professional having 10 years of experience across India's top tech giants as well as top notch data analytics firms such as TCS, Nielsen, Axtria, and is currently working at IPSOS Research, Bengaluru. His experience encompasses price, promotion, media efficiency analytics across CPG, retail, auto, and pharma clients from Fortune 500 companies, building econometric models and applying data science to a variety of business and policy problems to deliver robust solution is his passion and profession. I heartily welcome you, sir. Over to you, sir. Session is all yours.
Thanks for introduction, Chanda. I hope my voice is loud and clear.
Yes, sir.
All right. All right. So I'm just getting started by sharing my screen. I hope my screen is visible.
Yes, yes.
Okay. So first we'll talk about machine learning, and then different algorithms that we have in place. In what cases we will be using each of those algorithms, and we'll do hands-on with one of the publicly available data sets. It will be interesting because the data set has to do with how someone would default on paying their loans and things. So probably that's something we'll go through. Now, machine learning, now in this age of computer, we don't do calculation in our notebook. So we use the computers. So it's a machine doing all the calculations. Now, broadly, these definitions are not, fully watertight. So when I'm saying, broadly classifying these things into traditional versus machine learning, so typically, in school days or the college days, we will consider the regression problems as traditional statistics versus the machine learning or the data science applications as the modern or the machine learning algorithms that we have in place. Now, regression, it has also seen a sea change, building just a linear regression or maybe a polynomial regression is typically what we would use. Or there could be a panel regression, or maybe there could be fine tuning, hyperparameter fine tuning to adjust the regression models such that it is able to adjust the collinearity, or maybe running, I'm running the um, I'm building a model just to select the features. Features, I mean, variables in economics language. So that's how we will use the regression. So it is also a machine learning algorithm because with the read lasso that are more frequently used in the corporate world. It's just a regression, and that is, of course, a panel data. I think the next session is on that. So that is also widely used. So all these are a machine learning. It's just that probably, we consider it as a regression, and probably we think that machine learning is something different. Now, logistic regression is also something what we typically follows for binary classifications. A real-time use of the logistic regression was your COVID test. It was based on the logistic regression. So, it is not. That's where you see the penetration of how machine learning is going into, right? It is used in the pharma domain. It's just one of the diagnostics aspects, but of course it can be used in multiple other domains. Now, there are few clustering or classification algorithms I have mentioned. One of them is a support vector machine. I just briefly named it as SVM. That is a KNN, K nearest neighbor, K means clustering. So this can be used wherever you can apply the logistic regression, particularly the logistic and SVM can be used alternatively depending upon the data set and the business question. So that is something we can use. Um, Now when you learn about, when you start learning about machine learning, you will get frequent questions like, there is something called supervised machine learning, there is something called unsupervised machine learning. So any classification algorithm such as KN or KNN, that is, K nearest neighbor, or the K means clustering, both of them essentially runs on your Euclidean distance or Manhattan distance. So there are several distance algorithms that we have in place. Uh, so logics. So regression is also using some logic. So these are just an extension of it. Where here we now have instead the distance approach rather than you know frequentalist approach getting used. Now, today our main focus will be on first understanding the decision tree, and second the random forest. Now, it seems like we are talking about Amazon place where there is a tree and there is a forest. So both of these things. So there is a one tree. Of course, we'll talk about it, and then there is something we'll be talking about the gradient boosting. Uh, Now, let's just first talk about what the decision tree is. So if let's say there is one business question I have, I'm just thinking, from a programmer's mind, the software coder's mindset. So the software coder will think everything in the context of if, else, then condition, right? Now, just pulling in paint document, although it's very bad, my painting is bad, but yeah, you can see something. So let's say I want to see whether I can go ahead and play cricket today with my neighbors today on, right? So then if I can go ahead and play cricket, for example, versus I can play ahead and cannot play. So I'm just typing no. So now it depends upon what kind of condition it is there outside, whether it's raining or not. If it is raining, I cannot go and play cricket. If it is not raining, I can go and play cricket. Now, if it is not raining, then I will have to see whether it rained yesterday, whether let's say I'm just booking one box to play cricket, whether the box is available to play cricket or not. So that also becomes one of the no uh, for me to go ahead and play the cricket, right? Now, just putting this thing in the perspective of the data that we're gonna explore. So I'm just giving you a brief introduction of what kind of data that we have in place. So this is data we have from the Landing Club platform, right? It's publicly available data, for 2016. It has a column such as a credit policy. Credit policy means here whether the company thinks of allowing credit to that particular person or no. So it's kind of a P2P platform wherein that is one person who actually needs the money versus there are several investors who want to lend the money. Uh, Now that is something what this platform has devised whether this person should be given loan or not. So that is what is defined here. Now, based on historical data, our area of interest. So, what variable actually we are going to look is whether that person has paid up, paid their paid back, how frequently they paid back their amount. So that's what we're gonna uh, uh, investigate, whether they paid back or not. So that's our area of interest. Now we have several other instances like for what purpose they are asking, since this is historical data, right? We had an idea that why they were looking loan for, uh, what interest rate charge was charged for those person, what installment, that was that was charged, what's the annual income of that person, what the FICO score, so it's kind of your CIBIL score, um, and several many other variables. So that's just about the data. I'm just opening that file in Excel. So you get the visibility on what kind of data that is that. So there are as many as 10,000, approx 10,000 rows. And this is the variable we are interested in, whether that loan was fully paid up or not. Now, basis that we are training and learning, whether the person should be paid up or not. So that's just about the data. Now, jumping back to what decisions this decision tree would do. So here are some concepts that we will learn first and then apply in Python. So first, how exactly we get to know. So in this tree, there is one condition, then we are splitting into a tree, if and conditions, right? If else or if no conditions. So now this is something what we call as a node, this line. Uh, or rather path, and this is the mean. So if let's say if it is raining, then I am not gonna play the cricket based on historical data, right? Of course, that's not something what applies here. Given the data, we'll talk about we'll talk in terms of the data in some time. But yeah, uh, so here there won't be further bifurcations whether I will be going play or not. So this will be called as a pure node. So pure node means the decision is made, right? It's raining, so I'm not gonna play the game. So that's so in order to check that purity, we have a concept called entropy or the Gini coefficient or the Gini impurity matrix. Now that gives an idea whether this node whether I should go further below this or no. Now the question, so now talking again from the perspective of the data. So I have, uh, as many as 1,500 plus observations where the loan was not fully paid up. Now, if I were to train this decision tree, there are several many variables, right? Which one of to pick to take a starting point. Let's say maybe it's interest installment, or maybe it's of your CIBIL score or the FICO score. Let's assume if I were to start with the FICO score. So assume in our this decision tree whether that person will default or not. That becomes our primary area. Now here we'll have maybe we'll have some hardbound rule. Let's say FICO score of 750. From Indian context, I'm saying so any FICO score if it is greater than 750. So and so whether this person is default, I'm just citing this as a person as default. And here the CIBIL score is, uh, you know, greater than 750 and less than 750, right? So that becomes our kind of one branch of the tree. Now again, we'll see how many of the people. I'm just filtering out something greater than 750. So out of some 9,500 total observations we had, only 1,670 people failed. Uh, sorry, once out of, let's say, those who defaulted actually, right? So only 124 people have defaulted who had a um, credit score above 750. Out of how many? How many people defaulted actually? It's around 1533 something, right? So I can make a claim that almost 92% people are paying back their loan. So only 8% people are failing here, failing to repay this loan. So, so this is based on probability, right? So 8% is the probability of people, not paying back their loan. Now, basis this, the Gini coefficient or the Gini impurity will be calculated. The similar logic related to your probability of paying back versus non-paying back applies to entropy. Now, the question remains as to which variable should I select first, whether it should be your FICO or maybe it's based on maybe the interest rate or the installment that that person is currently paying or the purpose for which the loan was taken. Now that is determined um, based on the information gain. So information gain is nothing but the entropy of the parent node minus entropy of the child node. So entropy is, in simpler term, I can say the probability, right? Probability of I'm getting this 750 greater than 750 having just a 90, just 8% chances of having this default. And there will be a parent node, that is total how many defaults that we have. Just taking that ratio, we get to see where exactly which of the variable is giving us more information than the others. Now, basis that the prioritization of the each of the branch will take place. So first we add a parent node, then we have a child node, and then subsequently, let's say 750 is a 750 uh, credit score was one of the parameter. Now again, I will have a few more nodes, right? Now again, I have maybe I can take another as an interest rate. So if the interest rate is high, the person is more likely to default. Now that's something what I can define. I hope everyone is following, just to be double sure. So maybe I can, maybe provide more context or something.
Parti- Participants, you may raise your hand if you have any
Yeah,
query.
all right. It seems,
I-
all right. Okay. So I just want to gauge whether, the speed at which I'm going, whether that,
Yes, so they are
will-
actually putting their notion in chat box. They are following. They are able to follow.
perfect. All right. So now, since we, discussed something about decision tree, now we briefly talk about few other aspects. It's related to ensemble model. Now there are two type of ensembling models that we typically follows. One is a bagging and another is a boosting. So bagging is just called a bootstrap aggregation and hence it's called bagging. So B and bag. So that's why it's called bagging. Now in decision tree model that we just talk about, right? There is one decision tree that is already built. Now, not necessary, that is based on the full data set that we have, but it is susceptible to have a high variance. By high variance, I mean, in machine learning we have a two concepts, bias and variance. Uh, by variance, we mean, whether, if let's say I just want to apply this data set on a larger equation. Okay. Um, Okay. So just talking about the I'm just talking about the bootstrap aggregation. So in decision tree, is susceptible to have a high variance. By high variance, I mean when this model that we train, if it is applied on a larger data, or maybe some other data, uh, it is likely that we won't get uh, accurate predictions. So in order to avoid that, we have the ensembles model, one of them being the bagging model. So in this bagging model, what we do, we build something called as cross-validation. So let's say I have, let's say in our case, 10,000 observations. So I will have 10,000, let's say I'm just having a cross-validation of 5. That is 10,000 divided by 5. That is 2,000 data sets. 2000 observations. So, or maybe 5 is just a low number. I just consider few larger number. Maybe I will have a multiple models, multiple models which could have a sample size of 2000. So that's your raw with sample, with replacement. I will have, I will select some of the data sets. In our case, let's say 2000 data sets. I will not only have the selection in terms of the row, I will have selection in terms of the columns. So by columns, I mean features, in machine learning language. So if I have a multiple, several features selected for one models, do not selected for the another model. So thereby I will train, multiple models. Let's say 3,000, maybe 100 models, for example, with the sample data from the main data with replacement. Now, if I'm selecting such a model, now I have 100 such models. So on those 100 models, I will individually train the decision tree model. In decision tree model, what we did, uh, if a condition kind of, classification, whether person has a 750 plus score, less than 750 plus score, and whether, the probability of person getting default or not. Now, when we do such kind of exercise, now we don't only have a one tree. Now we have a forest. And that's why the next algorithm that we have, it's called a random forest. Now, because we have a trained model with, several, a subset of data with multiple features, different features rather, right? Now, when we aggregate this model and have just one classification, aggregate result, we would have a low variance. That means we can apply the same results to some other data set. So that's what
Sir,
the bagging algorithm
sir,
or the
sorry
random
for
forest.
interrupting in between. One of the participant has requested to kindly slowly explain the things.
Okay,
There.
okay.
Uh,
So of course, we will go through this once we, explore the data again. So it would be a kind of iterative. Yeah. Thanks for feedback. And then we have a few other kind of algorithm called as a boosting algorithms. We won't be, doing exercise for this one, but here I will have, let's say again, so XGBoost is one of the example of a boosting algorithm where we, let's say I'm just predicting one model. Now, the accuracy, I'm just using accuracy word, loosely here. We'll talk about what accuracy means, in some time. So once, let's say, there is a high error in that model, uh, that means the prediction we are not able to do significantly good. So what we would do, based on the previous model's error rate, we will fine tune the parameters and go ahead and train the model again till the time that we are able to explore that model for good day. Now here the things are happening at a sequential manner. So model is trained, it is getting retrained based on the previous error, and it is getting retrained, and retrained. Eventually, we are finally arriving to a concluding. So that's just about the boosting algorithms. I'm just exploring, this concept. Now, in machine learning, particularly, your one or zero kind of mapping, we typically split things into how exactly we validate those models. If it's logistic regression, we can use, maybe, you know, some parameter. In regression, you will essentially use your R squared, Watson and things. But when it comes to machine learning models, how would you get to know, that my model has uh, y- is robust enough to use for the next purpose? So of course, bias and variance are the two aspects, but in order to conclude, how much bias and variance are there in the model, we will use the confusion matrix. So in the confusion matrix, we have something called as a actual values and predicted values. So an instance where I'm able to my actual value is a one and predicted value is one, I will call it as a true positive, right? Um, Another instance where my actual value is zero. So in our case, the long data set case, the person is not defaulting, but I am predicting that person defaulting. So that becomes a false positive, right? And same goes for false negative and the true negative. So false negative would be the person is actually defaulting, and I am saying the person is not defaulting. My model is saying, right? Now, accuracy is what? accuracy is my true positive and true negative. So the correct predictions that I have mod divided by the the total observations that I had in the model, right? When all these four combinations are grouped, we eventually will have accuracy. Now precision, recall, and F1 score. Uh, this this features are used based on it depends on the usage of this KPI depends on the industry in which we are currently investigating. So let's say I'm investigating maybe stock market crash. So in that case, I will use precision or recall more frequently than using the accuracy. Now all depends. Eventually, everything boils down to what business question I'm trying to solve, and basis that I will select uh, the parameters that I will use to validate the model. On the right side, probably you can see the chart, which is just a AUC chart. We'll skip that for the moment, and now I will simply go to the, the data exploration. But before going to data exploration, if someone has to use Python, simply they can go to Anaconda download and download versions that suits their computer, right? Computer capacity. Why I prefer downloading Anaconda from and through Anaconda distribution is that it allows you to have a multiple IDs, everything in a one, everything is a one store. Now, I hope my Jupyter notebook screen is visible.
Sir, one of the participants is asking to kindly elaborate that how to download this Anaconda.
Okay. So if you go to this link, I think, let me see where it is. Um, yeah, I think by simply providing your email ID, you will be able
Mm-hmm.
to, you know, we will share the link. Maybe give me a second. Yeah, I think the registration is not required. Yeah. So let's say I have a Windows machine on 64-bit computer. I can maybe depending upon your computer, you can
Sir, if you could
see.
share the link
Yeah,
on chat
sure.
box.
It might take a little bit time because I think
Mm-hmm.
it's 300 MB plus. So yeah, it's 900 MB. And data set, I think, can I share it right now? Or I think uh, in the shared PPT I already shared. Or people want to try things out, simultaneously, or is it something? Uh,
Yes, sir. They are actually asking for the data set.
okay. Now, how can I attach the data set here? So if you open your Python in Jupyter, so currently I just open
Yes, sir.
through.
One is asking for the Jupyter link too.
uh, so let me just uh, show you how to download that. It will take a bit. I have actually downloaded it. I haven't opened the Jupyter notebook through anything. I don't have that on the navigator open. But once it is open, there we go. All you need to click on all you need to do is just open the Jupyter notebook and it will open, the Jupyter, the Jupyter link will open. So, yeah. So there are many, IDEs available. I'm just selecting, let's say, Jupyter Notebook, for example. Now, once it gets open, something like this would work. So I had, if I want to create one notebook, I think, yeah, it got open. Yeah. Currently it open in my C drive. I wanted to open it in D drive. So that's it. This got open here. I have one folder called JKey. All you need to go and select on this Python 3. So once you click on that, you will have a notebook, something like that. I hope this helps. Now, if you are doing this for the first time, probably you will have to install some of the libraries, because I have those libraries already installed. By just simply importing it works. I think in Python it does not require. I think, yeah. So simply if you follow this, import pandas, NumPy. So these pandas and numpys are publicly available, libraries which are frequently used. NumPy means, numerical Python. This is panel data. So that's why, abbreviated as a pandas. So nothing to do with, any jungle or something. Seaborn is one of the library to visualize the data. How I actually load the CSV file, that's done through this code pd.read underscore CSV. Launch is the data frame that I have created. Uh, Through dot info, I am able to see how many columns that we have, how many observations I have, and what data type that particular column has. Um, and launch dot head will give me idea on the
Say, is
file
data set
observation.
available?
How do I share that data set? I think I have shared that in PPT. Maybe I can share. I think here will it give me an option? No, right? To upload any data set.
Sir, if possible, you can share on our WhatsApp, then we can, circulate.
Yes, sir.
In what? So give me a second.
So
Uh,
even the Jupyter link.
Jupyter, as I said, right? Once the Anaconda
Mhm.
prompt is done, you click on, let's say, Jupyter Not. It will launch something like this. All you need to do is go and
Okay.
uh, Python 3. But of course, yeah, if you want to explore, whatever I have coded here, I will share that along. Uh,
Okay, sir. Okay, sir.
Give me a second. I'm just forwarding that thing over my email and then, share through WhatsApp. Yeah. In the meantime, probably people can ask questions, so we can have 5 minutes. Save that. And we will have a question and answer. So we briefly touched base on classification algorithms related to KNN or the K-means clustering, because that's something what we are not discussing is and we are mainly talking about the decision tree and the random forest, which is following which um, the bootstrap aggregation, the bagging. I hope the concept around these, concepts around, this impurity is, the Guinea impurity thing is also clear, right? That is on a fundamental level as to what it is to. forward it to one group. Do we have everyone in that group or oh, I think it's
Yes, I have forwarded it to the participant.
thank
Participants, hope you have received it on your WhatsApp group.
sorry for not sending that over, diary. I signed it over along with it is sharing back my screen. Um, shall we start? You just want to bring that thing in your laptop.
Yes, please. I have
Yes, sir,
shared with
please, sir.
them.
Yeah. Okay. So once the data is loaded, we simply reviewed, the observation. So this is simply, a view is similar to that what we see in typically Excel. So as I said, right, the pandas and library that we called. So pandas algorithm allows us to review data in Python in this form. Now, like in Excel, we have this data segment to review data's description. I simply done the loans.describe function, and then I'm able to see, what's the average, mean, median, 25 days, decile, 50 decile, 75 decile, and the maximum value for each of the numerical variable. Right. So, for example, if I were to see installments, so the average is 319. These are data is in USD. So 319 is in USD. The maximum goes up to 940, right? It doesn't seem like a lopsided data, right? It seems we distance in terms of the installment. If I were to look at the FICO, the credit score, it's 707 is my mean and 710 is my mean, 77 is my median. So it also since we have a normal distribution. Now, same goes for few other variables. Now, in order to see, explore the data, right? Now, I'm just simply putting the credit policy is something what uh, this company, what's it name? Yeah, the lending club, right? Lending club has identified whether that person should be given loan or this is not. Uh, so this highlighted through this color, blue versus red. And what's the FICO score of those people? So, so this company is deciding that people with higher credit score should be given loan versus those versus with low should not be given loan. And if they are given, the chances of them getting default is high. That's something what we see through this data. Also, so similar chart, but now instead of the credit policy as to what this lending club has decided, actually we are looking as to how many actual defaults happen. This is that. Since we have a few observations, right? There are few blues that we see here. So any credit score which is less than 660 essentially tells us that person is more likely to default than person with a credit score of 750. I just pulled data here only for the people who default on the majority. So this people beyond this below this are more likely to default versus here those you know the probability becomes 50-50 whether person is going to get default or not, because that's something what we see here. Now, of course, we see, some spikes, right? Because typically the credit score is rounded off, like someone having 750 credit score versus, so there are some uh, instances where there is high credit score. The number of people having the single credit score, and hence we see some of them. But that could be maybe smoother. Uh, for the time being, we are not doing that. And here is just a one chart that we created on the purpose of loan and whether the person got defaulted or not. Of course, this should have been looked from the angle of the proportion. How many is the proportion of loan related to debt consolidation failed versus maybe the other. So I just created another joint plot. This is just an exercise to visualize the data. So I have interest rate versus FICO score. So people having low credit score are having high have to pay high interest rate versus people having good credit score have to pay this credit score. Now I just added few more dimensions here and created, a regression line through the data. So people not paid versus people who paid the loan and how exactly the credit policy line would look like. So just a subset of the whole data and seeing how exactly those regression line could be fit between the interest and the fee given all this or to this credit policy and fully paid being two of the variables or classification variables. Right. So if you see the data, for example, um, I have one variable which is a category, which is a category, right? But it's in the numbers or the strings. Now, in order to convert that into, we cannot run regression or this analysis based on that data, right? So we have split that data. Uh, give me, give me a second. Yeah. So this is just one line of code that I created. I created blank, you know, one blank list, and I'm just adding, you know, a dummy variable for those entries. So here you can see, and of course, if you see here, maybe something as an econometrician we would be interested in, right? So drop first is equal to true. So out of how many variables we have? 1, 2, 3, 4, 5, 6, 7. I think there are 7 such purposes, right? I dropped one of them so that we don't fall for the multicollinearity trap in my random forest model that we are building. So here you see now all the credit, what the different purpose we take the credit, but true and false or the zero or the ones are. So I just defined all this variable in the x and y's. So anything which is not fully paid up is x, and anything and the not fully paid is a variable which I created as a y to simplify and run the model. Now, typically we do the train test split, so I won't train my model on this 9,500 data that observations that I have. So for timing, I have kept 20% of the data. So assuming, just rounding that off. So 10,000, 20% is around 2,000 observations that I just split aside. Um, so we are essentially training model on 8,000 observations. Now, first I'm building a decision tree model. It's, training a machine learning algorithm is very easy. All you need to, run only this line of code and you are able to train it. So, of course, that impurity and information gain aspects are something which is already taken care when we run this algorithm. It's just that we need to understand this aspects, the output with some context. So first, I just called so sklearn.tree and I imported the decision tree classifier algorithm. I just initiated a DT variable which is related to decision tree. I'm just fitting that DT variable with x trend and y trend. I'm predicting x text. X text is nothing but just a 20% of the data, right? Now I'm just doing so there is another package to check whether that particular uh, that particular how well actually the data fits. So or rather, just to check the accuracy, we have this classification report and the confusion matrix. So that's something I called. And when we print the report, I will first talk about the confusion matrix. So in our this file, we had this actual values, predicted values. Now this is something what we get. So here you see we are having out of, let's say, this is based on those 2000 data, right? The 20% of the data, because we trained model on the trained data. This is something what we are testing on whether, how well, those parameters that we learned in the trained model can be applied in the test data or not. And this is kind of two positive values we are getting. This is my true positive. This is my false positive, right? These are my false negative. These are my, yeah, true negatives. So this is something what I get. Now, when this is converted into percentage score, we get something here. So if I were to calculate the accuracy, my accuracy is 75%. So with the 75 accuracy, I am able to predict whether a person is going to, you know, whether the person is going to default. Now, as said, decision tree is highly susceptible to have a high variance. That is a model that is trained on one data. If another set of data is applied, it is more likely to give some error. Now, in order to see whether we can apply this thing on the random forest or not, we simply train the random forest model. And when we are checking the results, now the accuracy has increased to 83%. So here you see the number of estimators is 300. So I have, several many trees in the random forest model that we built, and that way we reduce the bias in the data, the variance in the data, and eventually the phone score in. Any question so far? Of course, this would be too fast to cover everything in 1 hour, but just a glimpse of what we can achieve, an overview idea on what the decision tree and the random forest.
So one of the participant has actually put one query. So please repeat parent and child node.
Okay. This becomes our primary node, the initial node. In order to show that, let me, pull in one another screen because, uh, give me a second. So I have one chart based on one another model that I built. Just to give you context, so this is around, so this data set is around one of the medical conditions of kyphosis, whether I will have a hump or not, present or not, depending upon the age and several other variables. Now here you see your initial prey. So your start is one of the variable. So let's say it is less than 8.5. So whatever, so this is a, angle from your starting. So this becomes your parent node, and all the below it becomes the child node. So for example, age being less than 11.5. So this become again parent node for the next model that I am building. So that's how it would follow. So ultimate aim is to have a full purity. Full purity means, have an eventual node where there is no further split available, right? So no further split means we have a 100% possibility of having either zeros or one. Zeros or one could be, in our case, having full default versus no default kind of scenarios given all the variables. So, any question?
Participants, if you are having any queries, please raise your hand. You can unmute yourself and ask question. I think they have understood the complete concept. There's no doubt.
Okay. Maybe you can try with the given data set. I will share with you the Python Jupyter notebook that I ran. Since we have time, probably I can give some more, uh, you know, thoughts on, few other aspects. Right. So we talk about, apart from these two algorithms, we talk about, some classifications. Um, so hold on, let me. So this is to do with this has to do with your split, the clustering of the things. So your key means clustering, or because of course that was not we just briefly touch upon that. So this is something what is used in your food, like food identification category. Let's say Pepsi would be using these algorithms in that machines to split whether the potato should be used in building potato chips or not, maybe. So that's something which is there in the system. Now, so here you see, right? In your class, everything is categorized, right? Here everything is just group. Now we have sorted these things out. Now uh, we will simply talk about, right? So there are, based on association, or we will going to group things up, whether one particular thing should be here. So this is something what happens. So typically we, everything is in the plan, right? Um, we just identify that, this thing should be grouped how and not. So for that, we typically use our key nearest neighbor and, key means clustering algorithm. So just an example as to, how the other two algorithms that we talked about are actually used in implication. All right. Um, so there are a few more variables that we had here. Um, few more validation scores that we have. One is called precision recall and at-one score. So just touching base on the model outputs, for example, here you see the your recall rate is just to 1%, versus in your decision tree, your recall rate is 25%. So, depending upon, what metrics that we want to optimize, we will select the variable, right? So one here means people who actually defaulted, zero means can defaulted, right? And here also, if you observe, out of 9,500 or 10,000 observation, only 1,500 observations were related to people who defaulted. So data was also lopsided, right? We had only 15% of the data where people defaulted, and only a zero, you know, people not defaulted had 85% of the data. So, the accuracy of people not defaulting is something what we predicted rather more robustly than people who actually defaulted is something what we are not able to solve here out of this model. Um, right? So this is just a one way of looking results, right? Random forest model, I'm able to get the more accuracy, but with this model, although the accuracy is low, but I'm able to have you know higher chances of committing the recall error. What exactly the recall error is? Let me see if I written. Yeah, uh, whether the correctly positive predicted outcomes out of the total number of positive outcomes.
Sir, majority of the participants are saying that the concept is very new to them. And if you could share more materials from the basic concepts to them.
Yeah, sure, certainly. Certainly. Yeah, because 1 hour is certainly not enough to,
Exactly.
go in all details, because otherwise we could have, talk more about how exactly entropy and Gini coefficients, because that's something ideally we should have been done, more time speaking here. But yeah, we had to, yeah. I will share some materials on this.
Okay, sir. Okay. I think none of the participants are having any further queries.
Yeah,
If you have, please raise your hand. You can unmute yourself and ask question. So it will be better to share the materials to them so that they can work on the basics.
yeah.
With this,
So,
yes, sir, please.
yeah. Sorry, go ahead. I will just something else. Yeah.
With this, I will express my heartfelt thanks to sir for sharing his insights. Thank you, Dr. Firdaus, team, Jammu and Kashmir Economic Association, and Jindal Center for Global South for organizing such an enlightenment session. Thank you to all the participants for joining us today. We appreciate your participations and hope you have gained valued insights into machine learning with Python. Have a great day and happy coding. Now, I would like to invite Dr. Firdaus to share a few words and propose vote of thanks. Dr. Firdaus.
So thank you very much for this wonderful session. I would like to take the opportunity to provide my heartfelt gratitude to our speaker and our moderator, Dr. Chanda Gulati. As we know, we were having very short time, and it is too much tough to learn such an advanced tool, Python. So it demands, I think, months to learn it from beginning to towards moving towards the applied tools like econometrics integration. But we were with the mission that we will try to introduce this Python and try to develop a motivation for our participants so that they will learn data. As all our recordings are published on our YouTube channel, we will be sharing that. As Sir has also promised that he will be sharing some material and some links where more insights can be learned about this new repository software Python. So once again, on behalf of Jammu and Kashmir Economic Association, General Center for Global South, I, w- I am thanking our resource person for accepting at a very short notice of time our invitation and provided your valuable time, especially the holiday Sunday. And you know we are having high regards for your devotion and for this dialogue, especially 1 week online international workshop empirical methods introduction to statistics, econometrics, and big data, which we are dealing since last 2 days. So I am once again thankful to you, sir. And special thanks to our moderator Chanda Gulati for running the session smoothly. So as I have highlighted, on Sunday and doing, family work and many more things are going, people on already for the week. But still, you have shown your, interest, and we are highly thankful for the session. So now I would take the opportunity to ask all the, participants to open their camera so that we can have separate group photo for this session. Please on your camera if you are in a good position. Let me hide non-video participant. So we are done with the group photo. So if you have to reach the resource person, we are going to tag him on LinkedIn and Facebook. You can reach him there with your queries and all. So with these words, I'm thanking to again our resource person and our moderator. Let us move to next session. So I am just inviting our next resource person, Professor Ram Pratap Singh, and let me take them. And we are having our moderator for this session, Dr. Jaskaran Singh. So we welcome you, sir, and we are looking forward to learn, panel data from Professor Dr. Ram Pratap Sinha, panel Econometrics with Grittle. So we are waiting for the great lecture. Over to you, Dr. Jaskar.
Am I audible? Hello?
Yes, you are.
Okay. Thank you, Dr. Firdaus and Jammu and Kashmir Economic Association and Jindal Global South for letting me to be the part of this important workshop. And very good afternoon, everybody present in this online workshop on econometric techniques for social sciences. As this is the last session of this day and this workshop as well. And I hope all of you attending the academic program have learned a lot through the various experts and lectures. And for sure, you are also excited to attend today's this last session where we are going to learn panel data econometrics in shaping our understanding of quantitative analysis in social sciences. In econometrics and statistics or in social sciences, when we see the panel data, it refers to a multi-dimensional data or cross-sectional time series data that generally involves measurement of some period of time of different variables. And but in particular, it is my absolute pleasure to introduce our distinguished expert, Professor Dr. Ram Pratap Sinha, who will guide us through this complex and vital subject and the use of Gretel software. And Professor Ram brings his wealth of experience and deep insights into this field. He is currently giving his services in Government College of Engineering and Leather Technology in the state of West Bengal. And he is having with 32-year experience in teaching and research. He has 108 journal publications to his credit, and he has contributed in 9 edited volumes. And besides, he has also written 2 books. He is a reviewer of many reputed international as well as national journals in the area of economics, finance, and marketing. He has also guided PhD and MPhil thesis of the area of economics and marketing. He has also taught and delivered his lecture in various faculty development programs, workshop, the area of data involvement, analysis, and econometrics. And we are fortunate enough to have someone of his caliber with us today to share insights that will enrich our future learning of quantitative techniques. And I think in the last, this is the last session of the day, and I don't think we need to give you any kind of instruction like, but for the formality's sake, I'm saying please keep your mic mute during the lecture, And in the end, you will get chance to ask your questions directly from Professor Ram. Now over to Professor Ram. Sir, please unmute yourself, and now you can start your lecture.
Thank you, Dr. Jaskaran Singh. Am I audible?
Yes, sir. You're audible,
Yes.
sir. You can start.
Hello, everyone. Actually, I was not in India and returned only on yesterday. So I requested JKEA to schedule my lecture in the last session. Now, as you are aware, my topic is panel data econometrics with Gretel. Gretel is a free to use software. I think other distinguished faculties have already introduced Gretel in this particular workshop. And so for the participants,
I believe this is just the beginning and there are millions of miles to go further. Dr. Malik, I hand over the session for final conclusion to you.
Thank you very much. So let me, put forward the straight forward the word is that without you, this workshop was not possible. So again, General Center for Global South, they were also the backbone who have helped us to organize this workshop smoothly. They have provided us the platform Zoom. Once we were, pre-planning this workshop, there were many institutions who asked us, let us, collaborate. But at the end, they were one way or other way unsuccessful to, join the objectives, what objective are, what mission we are carrying. So there are so many institutions across the globe. They are for the sake of workshop, conducting the workshop and conference. But our philosophy is totally different. We want to empower, we want to make the things, very affordable and accessible to all. That is why we are serious. If anybody was doing, any sort of indiscipline, then we were getting, aggressive and want not to have it, this indiscipline, so that our people on work will get stopped, or the disturbance will hinder us to work soon. So I again, once again for all the resource persons and moderators, they have joined the hands at one quick request. They have been available at our disposal and contributed in such a wonderful workshop. So thanks once again to all the participants, all the resource persons, all the moderators, the great institution, the Center, General Center for Global Center, OP Jindal University itself. So we are coming soon with new announcements, new event. So stay connected with us. Visit our website, Jammu and Kashmir Economic Association. There will be daily updates on our LinkedIn page about the recordings, about the photograph session, and everything will be available at your disposal. So with these words, I am thanking you again. Now there are important queries that we can discuss without